Welcome back. This is the second lesson recording for IM1, November 3rd, 2020. So where we've left was, I left you with these problems where you're supposed to evaluate each one of them and then figure out which ones are equivalent or the same in the result or which ones are different. So to do that, let's do evaluate first. Okay, so when you see this expression, 4 is being multiplied to parenthesis 10 minus 2. Okay, by order of operation, what we need to evaluate is inside the parentheses first, right? So 10 minus 2 is 8. 8 times 4 is going to be 32. Okay, what about the next one? We need to evaluate inside the parentheses first. So 4 times 10 is 40, minus 2 is 38. Next one is 4 times 10 is 40, minus 4 times 2 is 8. So 40 minus 8 is 32. And 10 minus 2 is 8 times 4 is 32. Okay, so which means that 32, 32, 32, they are the same. Okay, the one that is different is 38. So what is the same about the A, C, and D, and what is different about B is the location of the parentheses, right? So here, between A and D, the number 4 is being multiplied first or multiplied last. So when you're multiplying some number, the order does not matter. A and D, whether you multiply 4 after you, you always need to evaluate the parentheses first. So you have 8 here, whether it's 4 times 8 versus 8 times 4, you're still going to get the same answer. Okay, and then C, what we did here is we distributed the 4 to the 10, and then to that you subtracted 4 times 2. So 4 times 2 here. What B is how B is different is they broke up the parentheses and put the parentheses between between 10 and negative 2, and you're going to get a completely different answer. Okay, so let's continue. So that's okay. So what does distributive property do? So visually, if you have 3 rows of 5 cubes, okay, then we can break this up as 3 rows of 2 and 3 rows of 3, right? So visually, we're talking about same amount of cubes on the left-hand side of equal sign as to the right-hand side of the equal sign. And algebraically, we can express this as 3 rows of 2 plus 3, 2 rows of the blue and 3 rows of green, which is same as 3 times 2, 3 times 2, and plus 3 times 3. So if we were to do it algebraically, we have 2 options. Okay, so we have the choice 1 is to evaluate inside the parentheses first. 2 plus 3 is going to get you 3 times 2 plus 3 is 5, so that's going to be 15. Okay, the other choice is to distribute. We're multiplying 3 to 2, and then to that you're adding 3 times 3, and you get exactly the same answer. Okay, however, when you have a next example, 5 multiplied by 2x plus 3, okay? So again, if we were to do the 2 methods, one was to evaluate inside the parentheses first, the other was to distribute. Well, can we evaluate or simplify inside the parentheses anymore? No, we cannot, because 2x plus 3, they're not like terms, so we can't do anything with that, okay? So the only option we have is to distribute to make it simpler. Remember, when you see a number in front of parentheses without any operation, we mean multiplication. There is a default multiplication operation here. So 5 is being multiplied to 2x plus 3. So 5 is being multiplied to 2x first, and to that you are adding 5 multiplied by 3. So that's distributing, and you get 10x plus 15. All right, let's do some examples, and you should be taking notes on this. So when you're doing when you are multiplying 4x times 3x plus 2y. Again, what you're doing is you're multiplying 4x to 3x and 2y. So 4x is being multiplied to 3x, and then to that, 4x is being multiplied to 2y, and you are adding those two separately. So 4x times 3x is 12x squared, and 4x times 2y. 4 times 2 is 8, x times y is just xy. So you are left with 12x squared plus 8xy as your final answer. But we can do the area model that we've been doing. Okay, so but this time the width is 4x, the length is 3x plus 2y. So we're dealing with one term multiplied by two terms. So we're dealing with 1 multiplied by 2, 1 by 2 box, and then we can put the length 3x plus 2y at the top and the width, which is 4x, on the side, and you're just multiplying 3x times 4x. 3 times 4 is 12, 12x squared, because x times x is x squared. 2y times 4x, 2 times 4 is 8, and x times y is xy, so it's xy. And so for the area model, we get the same answer. 4x times 3x plus 2y is 12x squared plus 8xy. So basically, we're doing the same thing. Okay, the distributed property and the area model, we're doing the same thing. Okay, phew. All right, so let's see if you can do the distributed property with a more complicated problem here. 3m squared times 2m cubed minus 1 minus m minus 1. Okay, so again, remember that we're not just multiplying m squared, but we are multiplying 3m squared to 2m cubed minus m minus 1. Okay, so 3m squared times 2m cubed, 3m squared times 2m cubed. Okay, here we go. And then to that, we're adding 3m squared times negative m, and then 3m squared minus 1 here. And so then you get 3 times 2 is 6, and the m squared times m to the power of 3 is m to the power of 5. Okay, remember, it's not m to the power of 6. Even though you're multiplying, this is m times m, and then to that you're multiplying m times m times m, which is same as m to the m times m times m times m times m being multiplied to 5 times, not 6 times. Okay, then 3m squared times negative m. This is like negative 1 is being multiplied to 3, so it's negative 3. And m squared times m is m to the power of 3. And 3m squared times negative 1. 3 times negative 1 is negative 3. And then m squared. The final answer, when you simplify this plus minus, it just becomes 6m to the power of 5 minus 3m cubed minus 3m squared. And if you were to use the area model, the width is 3m squared, and the length is 2m cubed minus m minus 1. And you get, when you multiply each of the length times width for each of the rectangle, you get the same answer, 6m to the power of 5 minus 3m cubed minus 3m squared. So that what's inside is your final answer. Okay, so at this point, I would like you to pause the video and try this problem yourself. Okay. Okay, I'm going to assume you had a chance to do this, so I am going to do the problem. Okay, so your 4 is being multiplied to 3x, and then to that you're adding 4 times 7. So 4 is being multiplied to 3x first, and then to that you're adding 4 being multiplied to the second term, which is 7. So 4 times 3 is 12 times x here, and then 4 times 7 is 28. So that's your final answer. Second problem, again, you are multiplying 2x to 6x and then to negative 1. So this is same as 2x is being multiplied to 6x. 2x minus 1 is 2x. Okay, so negative, it's you are subtracting negative 1 is being multiplied to 2x. So, oops, did I do wrong? Okay, so I should Okay, so here we go. Is multiplied to 6x, and then to that, you're multiplying 2x times negative 1. Here we go. All right, so 2x times 6x is 2 times 6 is 12. X times x is x squared. 2 times negative 1 is negative 2. And then we're multiplying x. So the final answer is 12x squared minus 2x. Oops. All right, and then C. This time you're multiplying negative x squared. Remember, any negative sign belongs to whatever the variable or the number that follows, right? So negative x squared is being multiplied to 3. So negative x squared is being multiplied to 3. And to that, you're adding negative x squared, and then you're multiplying negative 5x. Okay, notice that I am using parentheses because if I just said negative x squared minus 5x without the parentheses, this is a very different expression, negative x squared minus 5x. Okay, they're not like terms. You can't combine this. You can't add or subtract this, right? Whereas when you're multiplying negative x squared times negative 5x, this parenthesis tells you that this is multiplication, not addition. Okay, so remember, because that's what we're doing, this negative x squared is being multiplied to negative 5x. It's not being added to negative 5x. So again, negative x squared is going to be negative 1 times 3 is negative 3, and then to that you're multiplying x squared. Negative 1 times negative 5. So it's like there's negative 1 right there. Negative 1 times negative 5 is positive 5, and x squared times x is x to the power of 3. Okay, so that's your final answer. And if I was to do the area model, it would look like this. Okay, negative x squared, 3 minus 5x. It's minus, don't lose the negative sign, okay? It's not 5x, it's minus 5x. 3 times negative x squared is negative 3x squared. And negative 5 times negative 1 is positive 5. X times x squared is x to the power. So again, you get the same answer. Negative 3x squared plus 5x to the power of 3, which is what we have. Okay, and then finally, 5y is being multiplied to y squared plus 3y and minus 2. So again, let's separate this. 5y is being multiplied to y squared. And to that, you're adding 5y being multiplied to 3y. And to that, you're adding 5y being multiplied to negative 2. Okay, so that 5 times 5y times y squared. That's just 5 times y times y times y. So that's 5y to the power of q, power of 3, plus 3 times 5 is 15, and y times y is y squared. And then to that, you are multiplying 5 times negative 2 is negative 10, and to that, you're multiplying 5y. So finally, I don't like this plus minus thing. I can simplify this as plus 15y squared minus 10y. Okay. All right. Okay, so how does distribution help me? You can solve this kind of problem. Okay. So again, what are we doing? We are multiplying 3 to 3x, and then multiplying 3 to 5, and then you are adding x to it that is equal to 65. Okay, whenever you see a distribution that is necessary, you need to do that first, and then you need to combine like terms. I see that 9x here and x here, so we have 10x plus 15 is equal to 65. So we need to subtract 15 from both sides, and then you get 10x is equal to 50, and then you need to divide both sides by 10, and you get x is equal to 5.